Hello guys, today we're going to be reviewing the second part of the talk, which is non-collision, mispronunciation, addition, NCMA, or accented ASR. The work has been published in 2021 Interspeech. The objective is that think about when you want to add mispronunciation into the dictionary so as to improve the phonetic alignments. Then with the better alignment, can you get a better acoustic modeling? So eventually, can you improve the word error rate of your ASR? Well, about maybe almost 30 years ago, researchers have started this effort, but none of them were very successful. Well, partly because look at this. Suppose I say the word absolutely, okay? You can also say absolutely or absolutely. These are variations, but adding these variations into the dictionary seems cannot help the acoustic modeling, which means there is something wrong, but nobody really looked into this, and I got really interested into this. And then I look into this pronunciation dictionary learning problem and try to address this accented ASR because in my mind, it does not make sense to still use the orthodox pronunciation dictionary in the training of the accented ASR because you can see me. Okay, I have accent, but lots of words when I spoke the word, I didn't speak in the orthodox way. But how does that affect the acoustic modeling? Should the acoustic modeling address my accent issue by looking at the pronunciation dictionary? For instance, how do we smartly add or delete the pronunciations of certain words into or out of the dictionary so to improve the ASR? This is a general objective. So let's look at the previous example again. So suppose you have the word decade, but I pronounce the word wrongly. I pronounce it as a decade. Okay, the mispronunciation happens. Well, maybe in the past people say, okay, I detect this mispronunciation. I should add that into the dictionary. But this is what I found. I think you probably should not add the mispronunciation into the dictionary, or at least you should add before knowing this, because this new pronunciation or this mispronunciation is actually colliding with the existing pronunciation term in the dictionary, the word decade. Okay, and then once you add this mispronunciation into the dictionary, during the decoding or recognition, whenever somebody says decade, suppose the language model is not very strong, there's no way for you to know whether the guy has mispronounced the word the decade or the person is indeed pronouncing decade. Okay. Then you make recognition errors. So this is why I developed the 3 constraints to decide whether a mispronunciation should be added into the dictionary. And of course, it leveraged the OEDN method I mentioned in the part 1 of my talk. Okay. There are 3 constraints: confidence, occurrence, and non-collision. First, confidence. I think you guys are familiar with GOP, the goodness of pronunciation. You can imagine this as a posterior of the phonemes or the word or the pronunciation. Okay, whenever these posterior of a certain pronunciation exceed a threshold, I would say it's very likely the mispronunciation occurred. And I call this confidence, or confidence score will decide whether a mispronunciation can be considered as a mispronunciation other than accent. Okay, you know the difference between mispronunciation and accent. So I have accent, but most time I do not make mispronunciations. Second occurrence is easy to understand. Only if the occurrence exceeds a certain threshold, you should add this into the dictionary. I think the first two constraints are not new. The third one is new, and this is what I proposed. So it's very simple and easy to understand. So the newly added pronunciation should not collide with any phonetic sequence in the orthodox dictionary. So in this way, I prevent a mispronounced word, a correctly pronounced word from misrecognized as mispronunciation. Okay, but you can say way, but in this way you reject the real mispronunciations to be included into the dictionary. I say yes, but the purpose of this constraint is just showing that with this constraint, I think this is almost the first time people can get better recognition result by adding mispronunciation into the dictionary. This is a good direction. This is promising. And if you say that you have some own ideas about whether I could keep certain mispronunciations, even the collision appeared, you can give it a try by yourself. So this is just to show that it's working. And using the example, so whenever the person say decayed, so the mispronunciation probably should not be added, and it's not added because it collided with the orthodox pronunciation of DKED. Okay. Here's the training set, test set, and depth set. It's all accented database. And here you can see some ablation studies. So the D1 is the baseline. You got 12.7, okay? So if you just use the first constraint, the confidence constraint, so whenever you felt, okay, this is very likely to be a mispronunciation, you added this into the dictionary, then your WER gets significantly worse. I think this is what most of researchers have been experiencing, and this is the same thing, because if you look at the number of the added words into the orthodox lexicon, it is more than 1,600. It's a lot, okay? Because the dictionary size is, I think, total number of mispronunciations. I think this is a number of words. There are about 3,500 words. And you add another 1,600 of pronunciation into it. So this is too many, right? And also when I add the occurrence constraint, so only if you have 2 or more than 2 occurrence of mispronunciations, you can add it. Otherwise, you just throw that away. Okay. So if you only use this constraint, okay, it's still getting worse. But you can see that constraint number 2 is better than constraint number 1, comparatively. And then, I'm sorry. So this is E2 is on top of the E1, right? So it reduced the WER of the second row a little bit, but it's still worse than baseline. Okay. But when you add the third constraint, NCMA constraint, or the non-collision mispronunciation addition constraint, the magic happens. So it's significantly dropped from the second row to the third row, and it's better than the baseline. I won't say it's much better, but it's significantly better. And you can see the number of the added words, the pronunciations, is about 300. Is 300 a good number compared to 3,500? I don't know. But the thing is, it's working. And I also tried that to increase the number of constraints. But you can see that as long as I increase this NA, the WR start to degrade. It's probably because it's losing the capability of modeling the mispronunciations. And then you can see that if you add the set the NA too large, there's not a lot of words that are being added, and the WR is slightly worse than the baseline. Okay. There are some more statistics if you're interested. So in the training data, about 500 words are detected with about 2,000 mispronunciations. So you can see that each word can have multiple mispronunciations. Okay, like absolute, 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 yeah. And that it only accounts for 1.5% of the word instances, and the affect about 20% of the lexicon. That makes sense because most time people make common mistakes about the common words, right? Okay, and it affects lots of the lexicon. So here I have a question for you, or it's like a homework. Suppose you have a L2 language model, so acoustic model. So acoustic model tries to handle the accent of the L2 learners. More mispronunciation would be detected with an L1 AM, but would that be good? Well, the short answer is no. The reason is that if you're using the L1A acoustic model, say the native model, to try to detect the mispronunciations, lots of time the model tends to detect the accent as mispronunciations. But definitely in the speech recognition, for the accented speaker, you want to use the L2 AM, right? You don't want to use the L1 AM. So this, you want the model to be relaxed or do not punish too hard on the accent and only try to find the mispronunciations. Okay. So more than 85% of the detected mispronunciations only occurred once. This is correct. Different people mispronounce the words differently. And not lots of mispronunciation have more than 5 occurrences. So this probably give you the idea of why adding more pronunciations into the dictionary is not a good idea, because you see the pronunciation of the words varies from different person to person, okay? And you add this pronunciation based on this type of person, but it may fail for other person, right? And our non-collision constraint eliminates about 1/4 of the detected mispronunciations. You might be surprised, only 1/4, but it's according to the numbers or the experimental results, it is this 1/4 of the mispronunciations that cause the recognition results to be worse than the baseline. And I think I just mentioned that before. Should that be always collision free? My idea is that you might want to avoid collisions, but if there are collisions, that might be fine, right? Because in the English dictionary, there are words with collisions. For example, the saint, prophet, okay? Prophet Muhammad, prophet word. And also, if you talk about earning calls, you have the word profit, gain, loss. These are the same pronunciations, but they are being mapped into different words, right? There's collision. But people can determine what word people are saying by looking at the context, right? So I'm gonna read this. Why our NCMA works? This is my thought. Might be not be wrong, might be correct, but this is my thought. Although a word that has its mispronunciations added could be better recognized, a word could also be wrongly recognized into another word whose mispronunciations collides with the orthodox pronunciation of the first word. And NCMA avoid this issue. All right, since this is part 2 and the last part, I will come up with our conclusions. First of all, the one added distance FSA based network, aka OEDN, can generate full mispronunciation rules and detect mispronunciations. And by doing this, you no longer need handcrafted mispronunciation rules by linguists, and you can perform mispronunciation detection and to improve your ASR or speech assessment purpose. You can do all of this. And second thing is that when you add pronunciations into the dictionary, you want to look at the method proposed by us. It's called a non-collision mispronunciation addition, NCMA. So it tries to avoid the newly added mispronunciations to be collided with the existing pronunciation items, and it proved to be helpful for accented speech recognition compared to traditional method, which usually do not work. All right, thank you for listening to our talk. And if you're interested, we have our own channel, and we have a meetup group. Feel free to subscribe, ask questions, and come to our bi-weekly meetup. And thank you so much. Goodbye.